let's start with the order of operations. I'm going to share the whiteboard now. Yes. Okay. Can you see my whiteboard yet?
It's loading.
All right.
I can see it.
Okay, so can you see it now? Okay,
Yes.
that's good. All right. So I'm going to put up an example, all right? Which one did they teach you guys, BODMAS or PEMDAS? Which one?
BODMAS.
BODMAS, okay. So let's just do a quick review of what BODMAS means. What does the B in BODMAS stand for?
Brackets.
Brackets, okay. How about the O? Do you remember what the O stands for?
No.
Okay, so that O, most people get it confused. They think it's off, but it's not off. Are you with me?
Yes.
Okay, so that O, there's a it stands for now it's not order as per order of operations. It stands for order in terms of power. You understand? Something like 2 squared or 3 squared. Okay, 2 raised to power 3. Do you understand?
Order.
Yes. Do you understand now?
Yes.
Okay, so what that thing is saying is that if you have an expression, are you listening?
Yes.
Please don't draw any circle. We're not dealing with circles now. What that thing means is that if we have an expression and you have something like 2 raised to power 3 involved in it, then if there are no brackets, that 2 raised to power 3 should be the first thing you should attend to. You understand what I'm saying?
No.
Do you understand what I'm saying?
No.
Speak out.
No.
All right, now I need you to undo that circle that you drew. Please undo it so that we have space to work. Okay. All right. So let me give you an example. Of course, you know that the D means division, right?
Yes.
All right. The M is what? Multiplication.
Multiplication.
The A is what?
Addition.
And the S is what?
Subtraction.
Okay. So now let me say something here before we start looking at examples. Division and multiplication. Technically, are you listening to me? Technically, they are on the same level. And let me explain what I mean by that. You know, there are some expressions where you see multiplication coming before division from the left-hand side, or division coming before multiplication. Anyone that comes first from the left-hand side is the one you will do first. Okay? Don't worry. Examples, you will understand better with examples. The same thing goes for addition and subtraction. When you see addition coming before subtraction from the left-hand side, you will do which one first? Addition. But peradventure, you see subtraction before addition, please go ahead and do the subtraction. Is that okay? Ugo, did you hear me?
Yes.
All right, so let's see some examples. Do you have some examples in your notebook there? You have some questions there in your book.
-4. Yes.
Okay, let's have it. Let's have the
-4
first
plus
one.
brackets -4 close brackets.
Let me hear it again. -4. Did you say -4?
Yes.
-4. Okay. And you're dealing with plus what?
Plus. No, only one plus.
I put one plus there.
Bracket -4 bracket close brackets.
Bracket -4. Like this.
Yes. And there's only one plus.
Okay. So what are you supposed to do in this case? We'll do the brackets. Now for this one, now we have to be careful because of that minus. You know, one thing that we must remember in maths is this. Anytime you see a bracket, you are supposed to imagine in your mind that there's 1 in front of that bracket. Okay, so just imagine that we have 1 there, okay, and that there's a multiplication there too. 1 times whatever is in the bracket. Are you with me?
So it'll be like -4 times 1.
So it will be like 1 times -4, because -4 is what's inside the bracket, isn't it?
Yes.
So this is what's going to happen. I'll have my expression will now look like this: -4. Now 1 times anything is that same thing. Am I right?
Yes.
Good. So +1. I'm taking that plus that is there as +1. Remember, we said every bracket has an imaginary 1 in front, multiplying whatever is inside. So we have +1, okay, times what is inside the bracket there is what? -4. So in other words, this is what is going to happen. -4 -4. Did you see what I just did now?
Yes.
Okay. Now, there are some basic things for you to understand when you want to get the answer to this thing. -4 -4. Okay. Now, if you have something like this, anytime you are subtracting from a negative number, it's as if you are adding to the number, but in the negative side. It's as if you are going to the left-hand side. If we had, let me see if we can quickly do this. You know your number line, right? Your number line looks something like this. A 0 is in the middle. You have, what do you have there? You have positive numbers, +1. Am I right? You have +1 on the right-hand side. What do you have after +1? +2. Okay. Something like that. Are you with me?
Yes, something like that.
On the left-hand side, you have -1. After 0, you have -2, and so on and so forth, right? Anytime you are subtracting anything, you are moving towards the left-hand side. Did you get what I just said? Ugo, are you there? Did you get what I just said?
Yes.
Okay, good. So if I say -4 minus 4. It's like saying start at minus 4 on the left-hand side and go further to the where? To the left. So that's why it said that minus 4. It's as if you are adding, but towards the left-hand side. So 4 plus 4 normally should be 8. But because you have minus 4, what will be the answer? Minus 8. Did you get that now?
8.
Did you get that now?
Yes. That's the same.
Okay.
Yes. That's the same way
So
we did it.
exactly. All right. So the answer to this particular question is what? Minus 8, right?
8. Yes.
Okay, it looks like I've gotten to the edge of my board. But anyway. Okay. So you know there's a minus there. All right. What's the next one? What's another example there that you have?
Minus 4 plus 3 minus 6 plus 10.
Hold on. Plus what? Plus what?
3 minus plus 3 plus 3 minus 6 plus 10.
Plus 10. Okay. Okay. All right. So remember what I said. Addition and subtraction are on the same level. Okay. But the
Yes.
first one that you see from the left is the one you would do. So starting from the left-hand side, what I see first is another minus 4. All right. And that minus 4 is there. You now have plus 3. Now, remember the one we did earlier was minus 4. When you have minus something plus something, it's a bit different. And the difference is this. It's there's a quick way that I usually use to do these calculations. I first ask myself, which of the numbers is bigger? Between 4 and 3, which one is bigger?
4.
4, good. Okay. Then the next thing I'll now do is to subtract the smaller one. Take note of what I'm saying. No? Just forget about whatever is there. We already know that it's minus something plus something. Subtract the small one from the big one. In this case, 4 minus 3 will give you what? Subtract the small number from the big number. 4 minus 3 will give you what? 1. Now, the next question is this. The answer, that one, will have whatever sign is on the bigger number. In between 4 and 3, which one is bigger? Hmm? Could you get closer to your microphone so I can hear you? Hello? Ugo, are you there? Check. It looks like your mic is muted. Are you there?
Yes, I'm there.
Okay. So I said between 4 and 3, which one is bigger?
4.
Okay. Now the sign on 4 is minus, isn't it? Right, Ugo?
Hello. Yes.
I can hear you now. Okay. So that means that the answer will be minus what? Minus 1. Did you get that now?
Yes.
Okay. So if you want to rewrite this question that you have here, this is how I will rewrite it. Since minus 4 plus 3 is minus 1, I'll just say minus 1 minus 6 plus what? Plus 10, right? Mm?
Yes.
Are you with me? Ugo, are you with me? Do you have any questions so far? Ugo, can you hear me?
Yes.
I said, do you have any questions so far? Hmm? Ugo, do you have any questions so far?
No.
No. Okay, so let's proceed then. All right, I think we have used up the space here. Let's add a whiteboard. Add page. Okay. Okay, can you still see the whiteboard?
Yes.
Okay. All right. Let me see. What was the last thing we had on that other whiteboard?
Minus 1 minus 6 plus 10.
Minus 1 minus 6 plus 10, right? Okay. So what do you think this one will give us? What do you think we should do next for this one?
Minus
Yes, go ahead.
minus 7 plus 10.
Minus 7 plus 10, correct. Remember, starting from the left-hand side, minus 7 plus 10. 7 plus 10 is going to happen. Remember that rule that we said we just used like 5 minutes ago or less than 5 minutes ago. When you have minus on one number, plus on the other, what do you think this will give us? Hmm?
You have to subtract
7 from 10, correct? That's the first one.
numbers
What next?
and add the minus. And add the minus.
And add the what?
Minus.
No. Remember, the answer will have the same sign as the bigger number. 7 and 10, which one is bigger? It's 10. So what sign is on 10? Minus or plus?
Plus.
So that means the answer will be what?
plus 3.
Thank you very much. Plus 3 or just 3, anyone you want. If you write 3, it's still the same thing. Okay?
Should I be writing it?
What did you say?
Was I meant to be writing this?
Please feel free to write it. If you've already done it in your book, writing it again will reinforce it in your mind. You'll be able to understand it better. Do you want me to
But
go
I
back to the
really
previous
like
board?
Yes.
Should I go to the previous board? Okay. All right, I've opened it.
And yeah.
Can you see it?
Yes.
Okay.
Should I also do the number scale like you did?
No, no need for that one. I was just reminding you of how it looks.
Okay.
If you want to be fast with your calculation, you need those rules that I shared with you, not the number scale. Number scale will slow you down.
You can switch to the next board.
Okay.
What did you write here?
Equals to.
Good.
Okay. All right. Were you guys giving any question that was more, that had more than just addition and subtraction in it? Was there anyone that had multiplication, division in the mix? Anyone like that?
No.
Okay. So all of them look like these ones that we just solved, right? Was there anyone that looked different from these ones that we just solved? Are you taking a look at your book?
My book.
Yes, check your book to see, are there any questions that look different from the ones we just solved?
There's no multiplication, there's no division, there's no order.
Okay. All right. So let's go on to the next thing then.
30 minus 3 bracket minus 4 close brackets.
Okay. So we're doing one more in this topic. So go ahead and write it on the whiteboard. Let's see.
Okay.
Okay, try your best to make it not too big, because now I can't, you may not be able to write everything there. Okay, you want to do text. Okay, text is better, yeah. Help you to be able to type. $30 minus 3.
Bracket close 4. Close brackets.
Is this the whole question?
Yes.
All right. Now I want you to give it a try. Can you try and solve it yourself? Let's see. If you make any mistake, I'll help you. Okay, why is it plus 12? Why do you have plus 12 there? Just explain it. I didn't say it's wrong. Just explain why you have plus 12. Go ahead now. Hello, are you there?
Yes.
You say you put plus 12 there. Go ahead. I didn't say that you are wrong. I just want you to explain why you put plus 12 there. You don't know why you did something. In maths, you need to be able to defend your steps. Now, the reason why plus 12 is correct there is simply the rules of BODMAS. Remember what I told you, that when you see a number, when you have a number in brackets, any number that is either to the left-hand side of that bracket, usually more often than not, to the left-hand side of the bracket, any number you see on the left-hand side of that bracket is multiplying it. Okay? So if you look at that bracket that has -4 inside, What number do you see to the left-hand side of that bracket? Hmm?
Yeah.
What's the number to the left-hand side of the bracket?
3.
You see, now you need to be careful. You don't just call numbers like that. You must call them with the sign in
Minus
front
3.
of them.
Minus 3.
Thank you very much, -3. And I told you that anytime you have a number in front of a bracket like that, what is the sign between that number and the number inside the bracket? What's the sign that is there?
Bracket.
No, multiplication. Multiplication. I said it. That was the first example that we did. Multiplication. So what that thing is telling me is that this thing that you're seeing in front of you is actually -3 times -4. And anytime you have minus something times minus something, the answer will always be plus something, right?
Yes.
Good. So that is why -3 times -4 is simply what? Plus 12.
12.
Did you get that now?
12. Yes.
Now, so the next line should be 30 plus 12.
Okay.
Please remember again, multiplication ranks higher than any other one. That is why we did multiplication first. It would have been very wrong to go and start doing 30 minus 3. And then you would say, but I did not see multiplication anywhere. No, there's multiplication there between that -3 and the bracket. Okay, so remember, in BODMAS, division and multiplication on the same level technically, but they are still higher than addition and subtraction. Those ones are, yes, they are higher. Okay, please take note. In fact, if I were to write BODMAS, this is how we write it. See how I will write it. Just watch me. I will write the B first. Sorry. Are you with me?
Yes.
I will write the B first, followed by the O, followed by the D, M, and then followed by the A and what? S. Why?
Yes.
Because this D and M are on the same level. Just depends on which one comes from first from the left-hand side. This A and S are on the same level. It just depends on which comes first from the left. Okay? But when you have a mixture of, say, multiplication and subtraction, or a mixture of division and addition, please take note. The division or the multiplication must be done first.
First.
Yes, you got that right?
Yes.
Okay, that's good. All right, let's do one more question just by way of, having one more exercise. One more question from BODMAS. Let's see it. You can type it on the screen. Have you written down this one in your book?
All the examples.
Oh, that was all, eh? Okay.
Yes.
All right. I want to give you my own example. My own question. Are you ready?
Yes.
Okay. So this is my own question.
Ya ka je hustle ọrụ onwe gị, ọ kara mma attitude.
Yes,
He had
ma'am.
to go and take in things.
Obido ememe ọ na-akpọ ndị ka ọ nyere m ya na ana obido datin ozugbo nwa ya nwaanyị nwụsịrị kechi ọ ga-echenji
Right.
ọ dịbụrụ otu a before ụmụala adịbụrụ otu a before he was very supportive and because I remember mgbe the IT just batara bịazie ịmago we are close ozi ka nwa ya nwaanyị nwụchara onye ga-echenji ọkazi mgbe ọ gazi nwetazi ya mee GM ọgbazie ya isi ọ bụrụ enwe nsị ga gwa gị ihe o mee one day
Nke a ịkpọ ya ozugbo.
today agaghị bịa na nkwụ ya
Can you do this one?
Over to
Which one? What do you think will be done first in this one?
the multiplication.
No,
Division.
no. Look at board mass again. Board mass B.
Bracket.
So go ahead and do the brackets first. Let's see what you have. What's inside the bracket?
7 plus 1.
What's 7 plus 1?
8.
Okay, now that you have done that, what's the next step? What's the next thing you will now do?
Times 3.
Good. 8 times 3 is what?
24.
Good. Finally, what's the next thing you will do?
24 divided by 2.
Excellent. 24 divided by 2 is what?
12.
Thank you. I hope you're not using a calculator.
No. I'm not.
I didn't say you are. I just said okay.
No, I'm
All
talking
right.
to my mom.
Okay. All right. So, do you want to write that one down since you don't have it in your book?
Okay.
Do you
On
remember
the
the
screen.
step? No, in your book now.
Oh. Okay. Equals 7
You have to
plus.
write down the question first. Write down the question first.
I've written the question.
Okay,
Plus
all right,
one.
go ahead.
8 times 3 equals 24. 24 plus 12. Done.
Okay, good. All right, let's now let's go to the next topic after board mass. What was the next topic you guys looked at?
Factors and multiples.
Excellent. That one is even easy.
Only wrote learning objectives on it.
We have learning objectives for that.
Yes, we only wrote learning objectives for it.
You guys don't have any examples on it.
We didn't write examples.
No questions at all.
No.
Was that where you guys stopped in the term?
Yes. No.
So you did another topic after that?
Yes.
So why did your teacher skip that one? What happened?
I don't know.
Are you sure? That doesn't sound right, though.
I know.
Are you sure someone else doesn't have a note that you don't have? Did you miss any class?
I don't think so.
Are you sure? You need to be checking your notes from time to time. Now it's exam time.
Okay.
How do we know if your note is complete now or not? Because your teacher cannot just give you learning objectives and skip that whole topic. It's good somehow.
Yes.
So see what we're going to do. Are you listening to me?
Yes.
I'm going to explain the topic, but tomorrow morning, first thing you're going to do as soon as you get to school, check everybody's notes. Check your friend's note. There must be something that you've missed somewhere.
Okay.
Let me add this thing to the whiteboard so that we can have space.
I already have space.
Where do you have the space?
Did you see the 8 I wrote?
No, because it's
Way
under.
down.
It's under. Okay, no problem. I can still use this board. Can you see space now?
What? There's
I
a
can see
lot
the 8 you
more.
wrote. I can see the space. Okay, no problem. I'll still use this board. All right.
There's a lot of space under.
Yeah, I know. I can see it. Okay. So let's talk about factors and multiples. In your times table, which one do you know up to from 2 to what?
2 to what?
That's what I'm thinking.
Thinking.
Is
Hmm?
it battery?
No, it's not battery. Sorry.
Are you there with me?
Yes.
He said he's thinking.
Okay. At
He's
least
thinking
you
of
should
the
know up to 12 now.
Yes.
Okay.
Skip 9 and 4.
Okay. So you should, I'm thinking you should know up to 12. Yes. So this is the deal, eh?
Or skip 9 and 4.
Skip 9 and 4.
Yes.
What is in that black
Mhm.
nylon?
Why are we skipping 9 and 4?
Not fully.
Okay. So this is the idea. This is the whole deal. I'm going to write something now. I'll try and use one particular one. Let's use 2 times table, for instance. Okay.
Okay.
2 times 1 is what?
2.
2. 2 times 2 is what?
4.
Good. 2 times 3 is what?
6.
6. Okay. Okay, let's stop here for the meantime. I want to just explain something. Now, 4 is a multiple of what?
2.
2. Okay. A multiple is the bigger number. Are you with me?
That's it.
The result of a smaller number times another number. Are you with me?
Yes.
Good. Now, same thing, we can say the same thing for 6. 6 is a multiple of 2 and what?
And 3.
And 3. All right. So 6 is a what?
Multiple.
On
Mr.
the
Charles.
other hand, yes, ma'am.
Mr. Charles, please, let me
Yes.
we just go back home now, so let's go upstairs.
Okay. Okay.
Let me
Okay.
help him
All
carry
right.
the just like 8 minutes
Okay.
or 5 minutes to go. Yeah, carry those things.
Okay.
You see that white sun? You cannot close the door. Bring that white plate too. Okay.
This thing, you think I can save that this thing again? Okay.
Oh, yeah, but that's not the voice.
Don't push here.
Nothing.
Food, cheese. You learn it. You start. You know. Yes, no. Remember to on the water.
Are you done?
Water pump.
Thank you. She'll go close the door. Here's my handbag. I'll come in the kitchen. Hello, close the door. And that's sit down with Mr. Krabs. Yeah, I don't have to better than listen to that person.
Hello, Mr. Charles.
Yeah, hi. Are you back?
Yes.
Okay. Okay. So I was explaining that the bigger number is a multiple, all right?
Yes.
The smaller number, the bigger number is a multiple of the small one, okay? And then you can also say that the small one is a factor of the big one. Do you understand now?
The small one is a factor of the big one.
Yes. So you can say factor of 6. And 3 is also a factor of what? 6.
6.
Did you get? Yes. So you got that right?
Yes.
Now, let me write it down so that you won't miss it.
So should I start? Let's
Should
start
you
from
start
2
what?
times 1. Start writing from 2 times 1, 2 times 3.
Yes, it's just an example. Okay, so there are some things I did not write in this, so let me write them.
Are you hearing something?
Where?
Vibration. Huh?
What did you hear?
Please change something.
Hello, that's Musa. Yeah?
Did you write 2 is factor of
Yes.
6?
In fact, it is safe to conclude that 2 is a factor of all. Do you agree with that?
Of all what?
All even numbers. All even numbers. 2 is a factor of all even numbers.
I agree so much.
Yes.
I've
In fact-
written it.
Okay, good. So here's something else for you to think about. Multiple divided by factor
No, sorry. That's a real, you don't mind, you can send it to me.
will
Yeah, I will see. This is really good.
always, sorry,
Yeah, but
will always
you don't mind, you can send it to me.
I'm hearing something.
Don't mind, you will
will always, please just listen to me, will always have a we always have a remainder of what? Guess what I want to write? Guess what I want to write?
Remainder.
A remainder of what? A remainder of what? You are putting question mark. I say you should guess what I want to write. You are giving me question mark. Remove that question mark. Let me finish what I'm writing. Remove the question mark, please. Okay. Remainder of 0.
Two.
Do you agree with that? Do you agree with that?
I'm not sure.
Let's take a look at what we have. 6 divided by 2 is what?
3.
Thank you. It's 3. Is there any remainder after that division?
No.
Exactly. If you try it for any, if you want to try, okay, let's even look at the times table that you say you're not familiar with. 4. 4 times 5 is 20. Okay? 4 times 5 is 20. Now, if you say 20, that means that 20 is a multiple of what? 4 and
4.
5. Isn't it?
Yes.
Now, if you say 20 divided by 4, that's 4 is a factor. 20 the multiple divided by 4 the factor. Will you have any remainder?
No.
No. You won't have any remainder. So that's the whole idea about multiple and factor. Now, what we just discussed now is, in a nutshell, everything you need to know about multiples and factors. Okay?
Okay.
So what we're going to do now is that your learning objectives, how many learning objectives are there?
3.
3. Okay, read them out. Let me hear. Let's see if we've covered them.
Coming.
Okay.
To understand prime numbers.
To understand prime numbers, okay.
Prime
We've not.
numbers and numbers. To write out
Come
prime
again.
fact. To understand multiples of numbers.
Okay, to understand multiples of numbers. That's the first one. What's the second
No.
one?
The first one is to understand prime numbers, even numbers, and odd numbers.
Okay, excellent. Okay, what next?
The second one is to write out prime factors.
Okay, what next?
And the third one is to understand multiples of numbers.
Okay, all right. So so somehow we have taken care of that third one. Am I right?
Yes.
To understand what a multiple of a number is, right?
Yes.
Okay. Now let us take care of the other two. The first one says to understand prime numbers, even numbers, and odd numbers, right?
Yes.
Now, you remember that time I told you that 2 is a factor of all even numbers. Do you remember when I said that?
Yes.
So that is like a fact. We can't change it. Mathematically, it's a fact. So let us now look at what odd numbers are. If 2 is a factor of all even numbers, then guess what? All odd numbers, when you try to divide them by 2, there will always be a remainder. Did you get what I just said?
Yes.
Let's try an example. 3 divided by 2 will give you what?
1 remainder 1.
Thank you. Let's try 15. 15 divided by 2 is what?
7 remainder 1.
Thank you. So did you see that there will always be a remainder, and usually that remainder is what? 1. Okay. So I'm trying to be as simple as possible with even numbers and odd numbers. Of course, somebody can equally tell you that even numbers are 2, 4, 6, 8, 10. That one is like everybody knows that. But you see, as I'm explaining it now, you need to understand it also from that angle. Odd numbers are the numbers in between even numbers. 1, 3, 5, 7,
9, 11,
11.
13,
So
15,
did you notice something? Did you notice something?
20.
Odd numbers are just like even numbers plus 1 in some cases. Or somebody can say even numbers minus 1. So for instance, to get 1, you have to say 2 minus 1. 2 minus 1 will give you 1. That's the first odd number.
2.
To get 3 odd numbers. I'm talking about to get odd numbers. You can get odd numbers from even numbers, right? To get 3, you can say 4 minus 1. Okay?
4, 1 plus 2.
No, if you do 4 plus 2, you get the next even number. Okay, 1 plus 2. Okay. Okay, so I did not want to follow that plus 1 because somebody will be saying, so are you saying that 0 is an even number?
Why isn't 0 an even number?
Well, technically, I can't say yes, because if we say that 2 is a factor of every even number, can you really say 2 is a factor of 0?
No.
Can you see where I'm coming from? So that's why I did not want to do that 1 plus 2. Instead, I'm going from the minus side. So to get an odd number, just say the even number close to it minus 1. Simple. Okay?
Okay.
Now let's go to the tougher one. It's not difficult. Please take note. I only called it tougher, but you will see that it is not difficult. What are prime numbers? Now, just listen to what I'm going to explain now. A prime number is simply a number that has only two factors, one and itself. Did you get what I just said now?
Yes.
Do you want to write it down?
Yes.
Have you written it down?
No, I'm writing will always have a remainder.
Okay. Okay, you're talking about odd numbers, am I right?
Of 0.
Okay, that one is for even numbers. Okay, write the one for odd numbers. That when you divide odd numbers by 2.
Should I write that one?
Yes, write it now. Because that's like a distinguishing factor. When you divide even numbers by 2, there will always be a remainder of 0. When you divide odd numbers by 2, the same 2, you always have a remainder of 1.
When you divide even numbers by 2,
When you divide even numbers by 2, you will always have a remainder of 0.
then full stop.
Yes.
When you divide odd numbers by 2,
Yes. You will always get a remainder of 1. You done?
yes.
Now, do you remember the definition I just gave you now for prime numbers?
No.
A prime number is a number that has only two factors, one and itself.
Should I write it?
Yes, please write it because we're going to be looking at examples now so that you see why I said that. A prime number is a number that has only two factors, one and itself. You don't write in?
A prime number
It's a number that has only two factors, 1 and itself.
comma 1 and
Itself. So are you ready? Let's look at some examples.
yes, I'm ready.
Good. Okay, so let's start with even numbers. Let's see if we can find prime numbers among even numbers. So what's the first even number that you know?
2, 3.
Excellent. Eh? Did you just say
No,
3?
sorry.
Please, oh, it's 2. Now let us see, does 2 qualify to be called a prime number? Does 2 qualify to be called a prime number? Let's consider it. 2 times 1 is what?
2 times 1 is 2.
Excuse me. 2 times 1 is 2. Is there any other way
Yeah.
you can get 2? Are there any other factors apart from 2 and 1 that can give you 2?
Any factor that can do.
Any 2 factors that when you multiply them, they will give you 2. Are there any 2 factors like that?
One times 2.
That's the only thing. So can you see that 2 qualifies to be called a prime number? Are you following me?
Yes.
Can you stop doing these shapes that you are doing? Please focus on our class, please. Please pay attention. So 2 times 1 will give you 2. That's the only way you can get 2. So what does that tell you?
2 is a prime factor.
2 is a prime number. No, don't say all. I never said prime factor. I've not come to prime factors yet. I've not come. Just leave that prime factor alone. Let's understand prime number first. Then you will now get what prime factor is. So 2 is a prime number. Now, let's consider numbers, even numbers higher than 2, and let's see something about them. Let's look at 6. Do you think 6 is a prime number? Remember the definition for prime numbers. A prime number is a number that has only 2 factors, 1 and itself. If 6 is a prime number, then we are saying that 6 has only 2 factors, 1 and 6. Is that true?
No.
Go ahead, defend your answer now. Why is 6? Why do you have more than just 1 and 6 as factors?
Because
We've seen that 2 times 3 is 6, isn't it?
yes.
And so that means the factors of 6 are 1, 2, 3, and 6. Did you see that now?
Yes.
Now, let me just summarize this thing for you so that we don't waste time. All the other even numbers except 2. That's why I said all the other ones. All even numbers except 2 can never be prime numbers. Why? Because we remember that time that we said that 2 is a factor of all the even numbers. Do you remember when we said that?
Oh.
Can you see that? So because of
Yeah.
that 2 being an extra factor, it has disqualified all of them.
Even 4.
Did you get the gist now? Even 4.
Yes.
Anyone you can think of in this world. The only even number.
124.
The only even number, if you like, call 1,024,000. The only even number.
1,000,000 and trillion, zillion, 25, 26.
Are you listening to me? The only even number
Yes.
that is prime is what? 2. Because 2 has only 2 factors, 1 and itself, 2. Okay? Now, have you seen that? Have you written it as an example that 2 is a prime number?
No.
Have you written it down that 2 is a prime number?
I should just full stop where I stop. Then 2 is a prime number.
Yes, because it has only 2 factors, 1 and itself, in brackets 2.
Because it has 2 is a prime number
because it has only 2 factors, 1 and itself, in bracket 2.
Then.
Okay, so you can now talk about the fact that all other even numbers can never be prime. And that's because they all have an extra factor of 2, including 1 and themselves. So there's no way they can be prime.
Then I should now.
Have you written that down?
No, I'm done writing to the prime number because it has only 2 factors and 2 factors, 1 on itself.
All other even numbers, can never be prime.
All other even numbers can never be primed.
Yes, because they already have an extra factor, 2.
Then full stop because they already have an extra factor, comma 2, full stop.
Yes, full stop. Okay. So let's talk about other prime numbers. Now let me ask you an interesting question. Can 1 be a prime number?
Nope.
Why?
Because it has more than one factor.
Because of what?
It has more than two factors.
One. Are you sure of what you're saying?
No.
I need you to be sure of what you're saying.
Who's Etel peas?
Hmm?
Who's Etel peas?
That's the name of the device I'm using. Are you with
Oh.
me now?
Yes.
So
Yes.
1 is not a prime number, but your reason for telling me that 1 is not a prime number is wrong. So I need you to correct yourself. Why is 1 not a prime number? Hmm? Why is 1 not a prime number?
Because
Now I want you to read the definition of prime number again out now.
a prime number is a number that has only two factors, one and itself.
Now ask yourself, 1, how many factors does 1 have?
1.
Thank you. Can you see that? Prime numbers must have 2 factors. Meanwhile, 1 has only 1 factor itself, 1, period. So can it be a prime number?
Oh.
Does it make sense now?
Yes.
Okay. So let us look at actual prime numbers now. Now, you in your mind, I'm sure you are thinking, so if all the even numbers except 2 are not prime, does it mean that all the odd numbers are prime? No.
Huh?
So are you ready to see some examples of prime numbers?
Yes. Yes, because 1 is not a prime.
That's just one example. Now let us look at the other one. Is 3 a prime number?
No.
Don't
Yes.
just say no. Think about it. Is 3 a prime number?
Yes.
Why?
I'm using this from what my teacher taught me in school. My teacher said that we have to use only prime numbers for this thing, for LCM. And I also use 3 for LCM. So that's why I'm saying 3 is an odd number. 3 is a prime number.
Oh, now I want you to tell me, based on the definition I just gave you now for prime numbers, why did you say that 3 is a prime number?
Because it has two factors, 1 and itself.
Only. Thank you very much. Finish. That's it. You're very correct. Let's consider the next one, 5. Is 5 a prime number?
Yes.
Let's consider 7. Is 7 a prime number?
Yes.
Let's consider 9. Is 9 a prime number?
I'm not sure.
You should be.
Yes.
No. 3 is 3 times 3, not 9.
Yes.
So let me just give you a quick cheat, a kind of cheat sheet. Anytime
Mm-hmm.
you can find two numbers that when you multiply them, we give you that number. Other
Mm-hmm.
than 1 and that number, then that number cannot be a prime number. So let us consider 9 again. We know that 9 times 1 is 9. Am I right?
Yes.
But because we can find 3 times 3, it has disqualified 9 from being a prime number. Did you get that?
Yes.
Because that means that 3 is also a factor of 9. Does it make sense now?
Mm,
Does it make sense now?
I think so.
Let it make sense. Let it sit down. Because once you understand this thing very well, you can explain it to anybody and it will not confuse you anymore. So, in other words, 9 is not a prime number, but it's an odd number. It's an odd number, but it is not prime. Now, let us consider the next one, 11.
11.
We all know that 11 times 1 is what?
11.
Can we find any other two
11 is
numbers
a
when you
prime.
multiply them to get? Thank you very much. 11 is a prime number. Thank you. Okay, let's move on. 13. Is 13 prime?
Yes.
Thank you very much. Let's consider 15. Is 15 prime?
No. Wait.
And why? Why did you say no?
Because 3 times 5 is 15.
Thank you very much. So 15 has been disqualified on the basis and platform that 3 and 5 are factors of 15, apart from 1 and 15, right?
Yes.
Thank you. So now you're sounding more confident. Let's move on. 17. Is 17 a prime number?
No. Yes, yes, yes.
Thank you very much. It is a prime number. Very correct. Because you will never find any two numbers. When you multiply them, it will give you 17 in this life or in the life
Yeah.
after. The next one, 19. 19, a prime number? Is 19 a prime number?
Yes.
It is a prime number. Now, if I were to ask you to list all the prime numbers between 1 and 20, you would go 2, 3, 5, 7, 11,
Yeah.
13,
That-
17, 19. Am I right?
Yes.
Good. So that is just
And
it.
20
This
is not a prime number.
yes, all these numbers are what that we just listed are what? Prime numbers.
Numbers. What's the difference between prime numbers and prime factors?
Beautiful question. Prime factors are simply factors that are prime numbers.
Oh.
Did you get that? Did you get that? Let me say it again. A prime factor is simply a factor that is a prime number, Let me explain. So let me give you an example now. We said, let's consider a number like 6, right? 2 times 3 is what?
6.
1
Oh,
times 6 is what? Cool down now, cool down.
6.
1 times 6 is what?
6.
So that's if I asked you to list all the factors, please take note of my question. I asked you to list all the factors of 6. You go 1, 2, 3, what? 6, isn't it?
Yes.
But guess what? 6 and 1 are not prime numbers, isn't it?
Yes.
Good. So that leaves us with only what? 2 and 3, which are prime numbers. And at the same time, they are factors of 6. Am I right?
Mm-hmm.
So you can safely say that 2 and 3 are what? Prime factors.
Factors.
Did you get that now? Nobody said that 6 is a prime number. Nobody. I'm just trying to say that a number may not be prime, but it can have what? Prime factors. Did you get that?
Yes. What
So,
about in 4?
what about what?
In 4.
24.
No,
Did you
4.
say 4? Okay. 4 is 2 and 2. So 1 and 4, 2 and 2. So that means all the factors of 4 are 1, 2, and 4, right?
Oh.
The only prime number,
Yeah.
the only prime factor of 4 is 2. You got that?
Yes.
Okay. So I think if you ask me, I think we have taken care of all the learning objectives. Am I right?
Yes.
Okay. So can we move on to the next topic?
LCM and HCF.
Okay. That topic is simple now, right?
Yes.
Okay. So I want you to do some examples for me. Are you ready?
Yes.
Okay. So I'm going to ask you, I'll put down the question now. Just give me a minute. I'm moving this thing upwards so that we have some space underneath. Okay. HCF and LCM. So I'll start with LCM questions. By the way, what's the meaning of HCF?
Highest common factor.
And what's the meaning of LCM?
Lowest common multiple.
Okay. Okay, so I'm sure you are ready for my question. So, what's the LCM? What's the L? This is LCM questions. Let me put it here. So, what's the LCM of?
1.
No, I'm not done. 28. Oh, no. Sorry. So, did you see the number that I put there?
40 or 4,
4,
8, and
12, yes. What's the LCM? Can you solve it?
that's what I'm doing now.
Okay.
What times here? What times here? 24.
Let me see. Correct. Very correct. 24. Well done. Okay. Let's do one question on HCF. So what's the HCF of
Okay.
Yes, question is coming. $14 and $28.
Okay. $14.
All right. I'll go with that. Okay. Excellent. Okay. Was there any of the questions that you were given in these ones that was a bit difficult?
Let me check. When I
Okay.
started off, that was difficult.
Okay, but when you got into the topic, it became easier, right?
Yeah.
Okay. So should we move on to the next topic?
Yeah.
All right. What's the next topic you have there?
Square and square roots.
That one is very easy now.
Huh?
Hmm?
Huh?
Is it not very easy?
Square roots.
Yes. Is it not easy?
No.
Okay. Don't worry. I was just joking. But let's explain it.
That same with most.
Okay, don't worry. I'll explain it. Just listen. You see it's easy. So let us talk about squares first. Hmm?
Okay.
All right. Now, I want to start with something like let's start with 3. Hmm?
Okay.
3 squares
The
is
square
equal
of
to what?
3 is 9. 9.
Is 9. Okay. Thank you. Is 9. The square
Square
of
is
4
simply
is what?
just 16. Square is simply just multiplying a number by itself.
Thank you very much. Now,
Yes.
the square root of 9 is what?
3.
Why is it 3?
Because 3 times 3 is 9.
Yes. So in other words, the square root is that number that when you multiply it by itself, we give you the number whose square root you are looking for, isn't it?
Yes. Is that
So
the
what's
shorter
difficult
method?
about yes? So what's difficult about square and square root?
I don't like.
What
We use longer method in school.
Okay, you had a different method in school.
Yes, the longer one.
Okay,
That
give me an
look like
example. Give me a question.
that look like this thing.
That look like
LCM.
what?
Or yeah.
LCM. Okay. Okay.
Let me show you.
All right, give me an example.
Wait, no. Let me do another one because you have already done 9. Can you see it?
Your writing is too big. But anyway, I'll try and manage it. It's too big.
I'm trying to reduce it.
It's still too big. Oh.
Too thick.
Okay, I'm seeing it. Don't worry, just continue.
Something like this.
Do you know why it's looking difficult to you?
Why?
You are using small numbers. You're using 2. Imagine you using 2 to be breaking down this thing continuously. Only 2. Can't you use other numbers? Can't you use 4? Can't you use anyway, Sha? The thing is that
It
really is you are
should
safe.
be.
Prime factors, okay, no problem. Really, you are safe using prime factors, okay? All right.
Mhm.
So, yes, I agree with that. I agree with that full time.
Like this.
Mm.
You now do.
Okay. You group them into 2, right?
Yes.
Okay. And then you take one set of the 2s.
Yes.
So is that difficult? It's not difficult now.
It's just to find that's what's difficult. To me, just to find this
See,
thing.
this is not if you are fast, if you are fast with it, if you are fast with it, you can quickly get the answer. Okay. So the answer is what? 20, right?
20.
Okay.
Up a lot of space.
Okay. Yeah, I know. So
Undo. Should I undo it?
no, it's okay. It's fine.
Are you sure?
All right. Yes, I'm sure. What's the next topic after squares and square roots?
Probably percentages.
Eh?
There's one that percentages.
Oh, percentages. Is that one easy?
Quarter. One part is easy, the rest is hard. The rest, wait, parts are easy, the rest is like this example we did for here. For me, it's now easy. When my dad explained it to me. Then
Okay.
when they say when they now say
When they now say what?
change 0.5 to 0. Change 1/4 to percentages.
Okay, to percentage. Okay.
Yeah.
So is this one difficult for you or it's easy?
No, when it's they say 1/4, that's what is hard. And they said
Okay. Is it that you cannot
25%.
do it? You know, there are 2 different things. It's hard and you don't know how to do it, or you
Hard
know how to do it, but it's just that it takes you time to get to the answer. Is that which of the hards are you talking about?
hard and I don't know how to do it.
Okay, so I'm going to do the example. So give me the example again. Give me the example again.
1/4 to percentages.
2, 1. Let me write it. Hold on. 2, 1/4. Okay. Okay. Percentage. Like this.
Like where? Yes.
Like this, right?
Change 1/4 to percentages. I have
Okay.
to change 0.75 to percentage.
You know how to change from what? Decimals.
To percentage.
You know how to change decimals to percentage.
Yes.
How do you do that?
Let me do it on the screen.
Okay. Okay, so that will give you 75%. Okay. Okay. So let me ask you a question. You want to change decimal to percentage. You simply multiply it by
100.
by 100. Okay. Does that not tell you something that if you want to change a fraction, that two whole number 1/4 to percentage, you also simply multiply it by 100.
Yes.
Mm-hmm.
No, the way
So now,
my teacher did it, I still understand.
I know I'll try and do it. I'll see. So I'll do my own method, and you tell me whether you understand my own method. So the important thing is for you to understand it and understand what's happening. So I want to multiply two whole number 1/4 by what? 100. That's the important thing right now. There are different ways you can do it. In fact, I think I'll do it in two ways. You tell me which way you feel is easy for you. So I'm moving it up now. Let me
Okay.
write two whole number 1/4. Okay. Two whole number 1/4. We want to multiply it by what? 100. That's the whole idea. Over 1. Okay, so there are two ways we can do this. You can do it like this. Change that two whole number 1/4 to what? Improper fraction. If I do that, what will I have? 4 times 2 is what? You multiply the denominator by the whole number. 4 times 2 is what?
8.
Then you add the number on top. 8 plus 1 is what?
9/4.
Thank you. So I have 9 over what? Over 4. I'll multiply that by what? 100 over what? 1. Now watch you. 4 into 4 is into itself is 1. 4 into 10 is 2. Remember what? 2. You put that 2 beside the 0. It becomes 20. 4 into 20 is what? 5. All right.
That's the same way my teacher did it.
So why is it? Did you not understand it as I was explaining it?
No.
This is the easiest way to do it. The easiest. Change the mixed number to improper fraction. Then multiply it by 100 over 1. Very simple. All you just need to do is to know your times table. 4 into 10, 2. How do I know? Because 4 times 2 is 8. And 8 is the closest to 10 in 4 times table. If you go and say 3, 4 times 3 is 12. That is above 10. Simple. So 2 whole number 2 remainder what? 2. The 2 is the remainder is gotten by that 10 minus 8, which is 2. Just put the 2 in front of the next.
I'm confused.
Where are you confused?
Everything.
Ugo, you need to open your mind to this thing. It's not, if you dismiss it as confusing, you've not even given it a chance to understand it. This is about the easiest way I can explain it. You have to just tell yourself that you can understand it and make use of your ability to understand. It's very easy. Now, again, let me repeat the process. The first step is to change what you call a mixed number. A mixed number is like 2 whole number, 1/4, where you have a whole number and a fraction. That's why did they call it mixed? Because it's more than one type of number, a whole number, and there you now have a fraction beside it. So it's a what? It's a mixed number. Please, it's not mixed fraction. Don't go and say it's a mixed fraction. That's a wrong terminology. It's a mixed number. Now, we can't work with it like this. We have to change it to improper fraction. And I just explained to you how to change it to improper fraction. You first take the denominator, which in this case is 4, multiply it by the whole number, which in this case is 2. And you told me that the answer was 8, isn't it? I now add the number on top, which is what? I now add the number on top, which is 1.
Before you
4
said
times
that.
2.
No, before you said that.
Multiply the denominator 4 by the whole number 2.
2, which is
Did you
8.
get that? Yes. Then I now add the number in front, which is what?
1.
1. So that is
just 9/4.
9/4. Thank you. Now I'm multiplying it by 100. Now I would have just told you 4 into 100 is 25, but it won't be fair to you if you don't know that. How did we get 25? So we broke it down. We said 4 into 10 is 2 times. If you're from your times table, you know that 4 times 2. 8 remainder. No, not 8 remainder 2. 2 times remainder 2. Okay? 2 times remainder 2. That means you will find 4 2 times in 10.
2 remainder 2.
Thank you. It's not 8 remainder 2. So the next thing we'll now do is to take that remainder and put it in front of the remaining 0 that's there, which will make 2 in front of 0. Is it not 20?
Yes.
And 4 in 20 is what?
How did we get the 5?
Because 4 times 5 is 20.
How did we get the 20?
Did you get it now? The 2, but that remainder that came out from the 10. Did you remember that 2 that came out from the 10? The remainder?
Yep.
Just put that remainder in front of the 0, the remaining 0.
The last one.
Yes, the last one. Thank you. The last one. That's how I got the 20. Does it make sense now?
Then now divided 4 by that 20.
Yes, and it gave me 5. I didn't divide 4 by 20. I divided 20 by 4. Because if you can say divide 4 by 20, that's another thing altogether. That's 4/20. But when you say I divide 20 by 4, then we're right. We're saying something. Okay?
Okay.
Next thing that we'll do, we have 9 on top. We have 25 on top. you will multiply 9 by 25. So 9 times 25 will give you what? Please don't use a calculator. Can you do it by yourself?
Come
9
on.
times 25. Yes, don't use a calculator.
What's it when I was about to use it? You just said it.
Because I knew you'll be tempted to use it. Let me tell you something about a calculator. A calculator will not allow you to use your times table yourself. And that's the secret to remembering times table is not by just saying it every morning, waking up and saying it every morning, and then getting to school and saying it in class. No, that is one way. But the secret, the real secret to knowing times table is to use it in your calculation like this. That's the secret. I'll not lie to you. Did you get the secret I just explained?
Yeah.
So any opportunity, you should come to a point where
125.
where did you get 225 from?
9
Okay, the
times
answer.
25.
Okay, thank you for that. So you should, what I was trying to say was you should come to the point where if your friend says, Ugo, let's use calculator, you tell your friend, no, we can do it ahead. In fact, a time will come when you will be so fast without the calculator that you tell your friend, I already know the answer. Your friend is busy trying to punch the calculator. You're giving him the answer before he's done punching. Do you think it's possible?
Yes. There's a man who is faster than a calculator.
There's a man, right?
Yes.
What's his name?
I don't know, but I just heard of him.
Yes, it's true.
Do you
He
know
actually,
his name?
I think he has the Guinness Book of Records for that ability. Very fast. Before you finish saying the number, he's already crunching it in his head, and he will spit out the answer before anybody is able to punch a calculator. I don't know. I'd forgotten his name too. I'm not sure now if the one I know is the same one you know, because Guinness Book of Records usually get reviewed over time. Somebody will usually come to challenge the previous one, and if you can get a math question done in lesser time, why not? He wins the Guinness Book of Records for that particular category. Okay, so you said the answer is what? 225, right?
Yes.
Alrighty.
I didn't even look in my book. I was just calculating. 9 times
Okay.
5, 45. Write 5, carry 4. 9 times 2, 18. 18 plus 4, 22.
Exactly. Yes. Yes, 225. So you know one thing, some people get surprised when they see percentages being more than 100. But this is a good example that shows you that it is possible, isn't it?
Yep. It's even more than 200.
It's even more than 200, so it's possible. So you can see that there is nothing difficult about this. Now, is this the only question that gave you some form of difficulty under? You can get up. You can get up to 1,000. Yes, it's very possible. Is this the only question that gave you some difficulty understanding under percentage?
Yeah. Uh-huh.
Hmm?
Uh-huh.
All right, that's good. So
Yes.
I think so.
Topic
That means
should be forms or area.
should be what?
Fractions.
Fractions. Okay. All right. So what did you learn about fractions?
1/5 plus 2/5, 2/7 plus 1/7, 3/1 plus 8/3, 2/5 minus 1/3.
Okay, those type of fractions, right?
Yes. First, you
Okay.
have to find the LCM of 5, which is
Right.
5.
Excellent. Mm-hmm.
then 1 plus 2.
Wait.
Then,
Calm down. Give me one question.
no, then
Give me one
5 is, wait,
question.
okay, 1 over 5
Mm-hmm. Mm-hmm. Plus what? Plus
Dot.
what?
is on top of you, on the right hand side. Plus 2 over 5.
1 over 5 plus 2 over 5. Okay, some denominators are the same here, right?
Yes.
So
bottom
LCM of
number.
5 and 5 is what?
5.
Okay, I solve it now. Solve it on the screen since you've written it. I was trying to write it down.
Okay. So, LCM of 5, which
Don't make
is
your handwriting
5.
bigger than this thing.
Then 5, 1. Then 5 is 5, which is 1. Then 1 times 1, which is 1 plus
Mm-hmm.
5 over 5, which is 1. Then 1 times 2, which is 2, which equals 3. Then 1 plus 2 is 3. 3 over 5. Done. I didn't write anything for square and square root.
Okay. All right. So this is good there. Times when you are told to show your working. Well, is there anything you want to write? Is there
Nope.
anything you want to write? I think it's quite
Nope.
straightforward. Okay.
Actually,
So what
gave
I
us
wanted
questions.
to say before you said that about
What you
what
say?
that you
What you say?
didn't write anything for square.
I can't
They
hear
actually
you.
gave
Your
you
voice.
questions for square and square root.
Uh-huh.
They gave you questions. They gave you questions for square and square root. Questions for square and square root.
Yes.
Okay. So we will solve that one, but let's finish this one first. I wanted to say that
It is 2 hours since we started.
but we're almost done now, aren't we?
Almost. We still have area, and I think after area there is. Oh, area is the last topic.
Hmm. So let's just finish this one. You'll see we're done. So anytime the denominators are the same,
Uh-huh.
do you notice that you can just simply take one of them and add the numerators? Do you agree with me? Hello, Go, are you there? What's the area of are you writing it down? Hold on, I'm opening the whiteboard. Can you see the whiteboard now?
Yes.
So what's the formula for the, all these things have formula. Do you remember?
Yes.
So what's the formula for area of a square? Let's pretend that that's a square that I just drew. Here is L. Here is L. What would the area be given by?
We only did triangle.
A equals L times what? L, which means that A, you guys do not do square.
No.
Okay, no problem. Let's go to the one that you guys did.
We only did triangle.
Did you say triangle or rectangle? What did you say?
Triangle. Triangle. Who's ETLP? Hello.
Ugo, can you hear me now?
Yes.
You said you only did triangle.
Yes.
So what do you mean area of triangle?
Yes.
Ugo, I need you to speak up now so that we can get done.
I said area of triangle. I said only area and perimeter of triangle.
Area and perimeter of triangle. So what formula did
I think we are in the first slide.
the first line? You've written it down somewhere.
Slide. Where bud masses.
Yeah, okay, you want us to go to the other one?
Yes.
Let me go to it now. That's page 2. Oh yeah, no. That is the second slide.
Huh?
This is the second slide.
Which one?
I said this is the second one now. So you said that you wanted the second one.
No,
I've opened the second one.
no, it isn't.
This is the
This is
second
the
one.
first one when we did.
This is the second one. We'll go.
When we did. I'm confused.
You are so quick to say you're confused. What is confusing you now?
I'm still on the one that said -4 plus bracket -4 bracket -4 -4 equals -8. Then now did the number line. 4 plus 3
Okay.
equals plus
Okay,
10.
that's what you are seeing. That's what you are seeing, right?
Yes.
Okay, don't worry. Let me stop sharing. Are you seeing anything now?
No, just ETLP.
Okay. Okay, it's opening up.
Okay. I still don't see it.
Yeah, it's taking its
Mr.
time. It's taking a
Charles.
while. I said it's taking a while. Hold on.